Hello everyone, I am Sonali. In this part we will learn next two type of sorting, insertion sort and selection sort. What is insertion sort? What is selection sort? See, name suggesting the insertion sort means here we are inserting the element at its correct place, means the insertion sort. And selection sort, we are selecting the one element if this element is a smaller, okay, it is the smallest element from this array, then we will put this element at the first location. Okay, in previous video we have learned the bubble sort. Okay, now we will see the insertion sort and the selection sort, and the example of insertion sort and the selection sort. In insertion sort is based on the principle of inserting the element at its correct place in a previously sorted list. So previously sorted list means what? Here we are considering the one whole array. Okay. Insertion sort. Okay, here we are selecting the element, we are inserting the element at its correct place in a previously sorted list. Okay, the definition of insertion sort is based on the principle of inserting the element at its correct place in a previously sorted list. Then which is previously sorted list, where we are inserting the element? Let's see first the algorithm of the insertion sort. Step 1 is, if it is the first element, it is already sorted, return 1. Means consider first element for the sorted list. Okay, consider the first element is sorted list. Okay, then next, pick the next element. Okay, if it is the first element, it is already sorted, means suppose in a list only single element, you consider it as a sorted element, and if not, if there are many elements, then consider first element as a separate list, and this is your sorted list. Pick next element, select the pick next element, select the second element. Okay, compare with all the elements in the sorted sublist. Compare this element with the other elements in a sorted sublist. Okay, means compare this element in a your first sorted list. Shift all the elements in the sorted sublist that is greater than the value to be stored. Okay, shift all the elements in the sorted list, means suppose there are the two elements in a sorted sub-sorted list, then compare this element with this 2, and if it is a less than this 2 element, then shift the locations and put this element at the first location, then insert the value, repeat until list is sorted. Let's see one example for this. See, here is your list. Here is your list. In this list, elements are 5, 0, 1, 7, 2, 6, 4. These are the given elements. Consider this first element is a sorted element. Okay, because single element is always a sorted. So first consider this element as a sorted element and put this element inside the sublist sorted. Okay, see, initially this is one whole list, single list. Here we are creating the sublist, this 5, taking the only single element from this list. This 5 is sorted, and here is a list of unsorted elements. Next element is 0. Select this 0, compare with this sub-sorted list. If this element is less than this, then shift this element to the next location and put this 0 at the first location. Okay, so 0 is here, 5 is here. This is a sorted list and this is unsorted elements. Again, take a 1. Compare this 1 with this sub-sorted list first element. Compare 1 and 0. 0 is less than 1, so don't change the location of this 0. Then compare 1 with the 5. 1 is less than 5, so put this 1 here and shift this 5 to the location plus 1. Okay, suppose here is your location, then location plus 1. Next element is your 5. This is our unsorted elements. In this way we will do till the end of array. Next select the 7. Compare this 7 with the 0, and 0 is less than 7. then compare the 7 with the 1, 1 is less than 7, compare the 7 with the 5, 5 is less than 7, so as it is, then put this 7 at the end of this sorted list, so 7 is here. Now here elements are 2, 6, 4, okay, again take the next element 2, till what, till the end of list we are taking the elements, 2 with the 0, 0 is less than 2, put here, compare 2 and 1, 1 is less than 2, put here, then compare 2 with the 5, okay, compare 2 with the 5, 2 is less than 5, so put this 2 at the location of 5 and shift this by 1, okay, now 5 is here and 7 is here also, okay, the location of the all the elements next to this will change. Now here elements are 6 and 4. Now compare this 6 with the from the starting to the end of this list, 6 to 0, 6 to 1, 6 to 2, 6 to 5, okay, 6 to 7, okay, then 7 is greater than this 6, so shift by one location, put this 6 here. And then our last element is 4, okay, compare this 4 with this, okay, compare this 4 with the 0, 4 with the 1, 4 with the 2 and 4 with the 5. But when we are comparing this 4 with 5, then 5 is greater than 4. So shift all the element, see, shift this element by 1 and put this 4 here. Okay, put here, see, here compare this 6 with the 0. 6 with the 0, 6 is greater, so no need to swap it, no need to change the location. Then 6 with the 1, 6 with the 2, 6 with the 5, compare 6 with the 7. When you are comparing 6 with the 7, 7 is greater than 6, then shift this 7 by one location and put the 6 here. And here is your last element 4. Now compare this 4 with the 0, then compare 4 with the 1, then 4 with the 2, then 4 with the 5. When you are comparing this 4 with 5, then 5 is greater than 4. So shift by one location and put this 4 here. Okay, so this unsorted list is not there. Okay, now all the elements are in sorted list. Your sub list is this 0, 1, 2, 4, 5, 6, 7. Here we covered all the elements of array. In this way you can use the insertion sort algorithm. Let's see algorithm one more time. See, if it is the first element, it is already sorted, return 1. Pick the next element. Okay, pick the next element, take this next one element. Compare with all the elements in the sorted sublist. See, compare this element. Compare this element with all the elements and then shift all the elements in the sorted sublist that is greater than the value to be sorted, and then insert the value. Repeat until list is sorted. Repeat until list is sorted. See function for the insertion sort. Here void insertion int a. See, here is your array. Here is number of elements in your array. I, j, temporary. I equals to 1, I less than n, I plus plus. See, here we are using the I. Here to here, I to n. Okay, for the all the elements. Then for j equals to I minus 1. Okay, this j equals to I minus 1, j greater than 0 and a of j greater than the 10. Okay, here we are using the first temporary equals to a of I. We are inserting this element into the temporary first. And then for j equals to I minus 1. Initially, j equals to I minus 1, location minus 1. Then j greater than 0. Suppose I is here 1, then 1 minus 1, take the j is equals to 0. J is greater than the 0 and a of j greater than the temporary. Then only do this, a of j to the a of j plus 1. Suppose this a of j greater than the temporary, then only put a of j to the a of j plus 1. Means suppose this element is greater than this element. Okay, when we are, let's see here, this is your list. Okay, suppose this element is a greater than this. Okay, check this, greater than or equals to. If this element is a less than this, then only put the element here and shift by location 1. Otherwise you can directly put, suppose in this case, see, this element is a greater than this element, so directly put do the addition. Okay, addition of pointer means directly shift this element, this 7 element at the end of sorted list. If this element is greater than this element, directly write the element here, and if this element is less than this element, then put this element here and change the location of this element. Okay, otherwise temporary to the a of j plus 1. Close the bracket here. Okay, in this way you can use the insertion sort. See, for the insertion sort, this is your definition. These are the steps for the algorithm. Compare this algorithm with this example for better understanding, and then see this C code. Next is our selection sort. What is selection sort? Here we are selecting the elements and then we are inserting this element. Okay, the sorting algorithm iterates through the array and find the smallest number in the array. Okay, here we are selecting, we are find the smallest element in the array and swaps it with the first element if it is smaller than the first element. Okay, here is our algorithm for the selection sort. Step 1, set minimum to the first location. Okay, first is our minimum to the first location. We are setting this minimum value to the first location. If any element less than this minimum is found, then only we will do the next procedure. Search the minimum element in the array. If found, swap the first location with the minimum value in the array. Assign the second element as a minimum. Okay, now second element is our minimum. Repeat the process until we get the sorted array. Let's see this with the help of example. See, here is our example. 4. Okay, this is our minimum value. Consider this is minimum. If any element less than this found in this array, then we will swap these two. Okay, 4, compare 4 with the minus 2, then 2, then 0, then 3. In this remaining list, the minimum element is minus 2. So swap this minus 2 with 4. So minus 2 is here and 4 is here. Okay, now set this second element as a minimum element and search for the element less than this. So 2 is less than this, but let's see one more, 0. See, 0 is less than, this is the smallest element of this array. Okay, then swap this 0 to the 4. So 0 is here, 4 is here. Now consider next element, this 2 is our minimum element. Now compare this 2 with this, find the smallest element in this remaining list. 4 is greater than 2, 3 greater than 2. Okay, so no more element less than this value. So insert this element as it is. Okay, now set this value as a minimum. Then compare this and search the value less than this in a remaining list. So 3 is a less than 4. So swap 3 here and 4 here. Okay, in this way till the end of the list, search the smallest element in a remaining list and swap it with the minimum value. See, set minimum to the first location, then search the minimum element in the array. Then swap the first location with the minimum value in the array. Swap the first location with the minimum value in the array. Assign the second element as a minimum, means this assign the second element as a minimum. Then repeat the procedure until we get sorted array. Program for the selection sort is, here we are using the array n, I, j, these are the different variables. This is a variable declaration. Enter the number of elements in array. Accept the array elements. Suppose 5 elements, then accept this element here. For I equals to 0 to n minus 1, I plus plus. Here minimum equals to the I. Assign this I to the minimum. for j equals to I plus 1, j less than n, j plus plus. Okay, here j is starting from the I plus 1 because here is suppose I, then here is your j, next is your j. Then if a of minimum is greater than the a of j, see any value c is greater than this, means this 4 is suppose greater than the minus 2, then j equals to, j set the j to the minimum. If minimum not equals to I, then here need a swapping, temp equals to a of I, assign this minimum to the a of I and then temp to the a of minimum. Okay, first do this. After this sorted array in ascending order, okay, here print the sorted list, print this sorted list. In this way you can perform the selection sort. Try this algorithm with the help of different examples. Take a different example and try to solve this. Thank you.